So I will briefly be talking a little bit about natural language explanations, and I want to start by basically telling you what natural language explanations are. Wilson mentioned briefly image captioning, but natural language explanations are, I would say, a little bit more than image captioning. So imagine you have, in this case, a chest X-ray, can be another image modality, and you have either a human, a radiologist, or an AI model that's producing a report describing the whole image, all the findings in the image, everything that can be observed. So this would be what we would call like the full description of the chest X-ray, or as Wilson mentioned before, the image caption. So this would be what we also see in medical reports. However, a natural language explanation would be we can think of it as just part of that description of the whole X-ray or of the whole image. So a natural language explanation would be why the radiologist or why the model is saying that there is pneumonia in this chest X-ray. So this would be the natural language explanation. And so just to see it in another way, a natural language explanation is a textual description, but not of the image. It's essentially a textual description of the decision-making process, in this case, of course, of the AI model, and the decision-making process for that specific image. So we can think about it as a natural language explanation being basically the combination of the model prediction plus the image description. That's why I said it's a little bit more than just, let's say, describing the model, the image, sorry. And why are natural language explanations needed? So Mauricio did a terrific job in explaining why some kind of explanation is needed, specifically in medical use cases. But why might we need specifically natural language explanations? So first, they are intrinsically understandable by humans. I don't know about you, but sometimes when I look at those saliency maps, it's hard for me to really extract some useful information as to how the model decided. Of course, different people have different preferences. Some people prefer to or capture information better visually. Some people prefer to read it. And of course, we can always have both. They are complementary to each other. So while, of course, visual explanations are more precise spatially, they have information for each region of the image. NLEs, natural language explanations, are more meaningful semantically, let's say, more globally. And of course, as I've said before, this can also be useful in the medical domain because radiologists also explain their diagnosis by producing the medical reports. I just want to highlight here a recent study that was done with 85 healthcare practitioners in this context of human AI collaborative chest X-ray analysis, and they evaluated essentially visual explanations, specifically saliency maps, kind of against NLEs, and also combining both. And for the sake of time, I'll just give you the high-level results. So they found that NLEs are the most preferred, so they were the top ranked modality of explanation preferred, and saliency maps were the least the least preferred type of explanations. But they also found that NLEs on their own lead to over-reliance. Okay, so basically people are more likely to agree that the AI model is correct when they see the natural language explanation, even if in fact the AI model is incorrect. So I would say NLEs are more convincing as to the AI decision. But interestingly, when combining both explanations, both visual and textual explanations, the accuracy increased. So humans predicted better if the AI model was right when they were presented with a combination of both NLEs and visual explanations. So again, here a bit of on the complementarity of the different modalities of explanations. And of course, here they only evaluated NLEs and visual explanations, but they could also have included things like Wilson mentioned, like example-based explanations, concept-based explanations, any kind of explanation, really. Finally, I don't want to really bore you with the technical details on how they can be generated, but there are several examples in the non-medical domain. Here are a few of the names of the models that exist. I can get you the links if you want to. In the medical domain, to the best of my knowledge, for now, I think only kind of these three works. But and for the sake of time, of course, the thing is, all these works that exist on generating NLEs operate in a similar way. And what I mean is, of course, with some or other nuance here and there, but they require the full supervision of the generation of the NLE. And this means that they need at least one sample of text produced by a human, in a medical case, for example, for chest x-rays by a radiologist. So they need one, let's say, sentence per each disease, per each x-ray. Because what these models are doing is, okay, I have this image, I have this disease, and I want to produce this sentence. So word by word, I will force my model in a certain way or encourage my model to produce this exact sentence. And this can be problematic. First, this is highly costly to obtain. It's already costly to obtain, the predictions for each X-ray, for each image. So to also obtain the sentences is costly. And then we have, of course, multiple correct ways of describing the same thing. So why should we force our models to produce that exact sentence? And furthermore, usually, of course, when we collect these data sets, we only consider the correct cases, that this image has pneumonia, so I will give the explanation for pneumonia. The thing is, we are explaining the models. We are not explaining the images. So we would need like an infinite amount of ground truth sentences for all the possible decisions that all the possible models that we want to explain would have. And this, of course, is infeasible because keep in mind, we want to explain not the image, we want to explain the decision process of the model. So we would need sentences for all the options that these models would produce. And of course, that would also depend on the AI model being explained. So imagine you would need at least one sentence per model, per image, per disease. So that would be absolutely infeasible. And so sorry?
Final minute.
Yeah. Last slide. So I just want to leave here some food for thought. We would, I guess, we would have two ways to approach the problem. We could have NLEs for all these cases, maybe generate them automatically with LLMs to help them train our systems. Or we could go the other way and could we generate these NLEs without this full supervision? That's what I've been working on. But still, even like if the problem was solved, there remains also the question, how can we evaluate these explanations? Again, multiple ways of expressing the same thing. Also, if we want to adapt to different audiences, how can we do this? And again, the model can be wrong, but the explanation might be right regarding to the model. So I leave you these kind of open questions. How can we do this without full supervision, without needing all of these sentences for each case, each disease? Thank you very much. Sorry if I spent a little bit more time.